So we're going to continue with the delta epsilon definition of limits. So our problem is limit as x approaches c of f of x equals 0 if f of x is equal to 2 of x when x is less than 0, or x of 4 when x is greater than 0. It reads, let f of x be a function defined on an open interval about c, except possibly at c itself. Then the limit of f of x as x approaches c is the number L. If for every number epsilon is greater than 0, there exists a corresponding number where delta is greater than 0, such that for all of x, 0 is less than the absolute value of x minus c, which is less than delta. It implies that the absolute value of f of x minus L will be less than epsilon. And this limit is written as follows, which is basically telling you the definition. So, in this statement, limit of f of x equals 0 as x approaches 0. 0 corresponds to both c and L in the equation. Limit of f of x equals L as x approaches c. Sorry, this is supposed to be c. Therefore, prove the statement by showing that for every number epsilon is greater than 0, there exists a corresponding number where delta is greater than 0, such that for all of x, 0 is less than the absolute value of x minus 0, which is less than delta. Implies that the absolute value of f of x minus 0 is less than epsilon, which can be rewritten as 0 is less than the absolute value of x, which is less than the absolute value of delta, which then implies that the absolute value of f of x is less than epsilon. So, we're to first consider when x is greater than 0. So they give us the absolute value of f of x is less than epsilon. So when x is greater than 0, f of x will equal x over 4. So then you substitute that in. X over 4 is less than epsilon. This can be rewritten as negative epsilon is less than x over 4 is less than epsilon. We then try to get x by itself and multiply each side by 4 to get negative 4 epsilon is less than x, which is less than epsilon. Next, it asks for when x is less than 0. When x is less than 0, f of x equals 2 of x. So then, absolute value of f of x will be 2x. This again can be rewritten as negative epsilon is less than 2x, which is less than epsilon. And we divide each side by 2. So then you have negative So we're trying to find when the inequality f of x is less than epsilon holds true for all numbers, positive or negative values. And this is the number in which it holds true for all positive and negative values, which then this implies that 0 epsilon over 2, which then implies that f of x is less than epsilon for any positive number. Then E will prove that the limit of x approaches 0 of f of x equals 0. And we're done.